Let's pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in prede, contra nequitia et insidia siatum, est presidium. Imperet illi Deus, suppligens te pregamo, tuque princeps militiae celestis, Satana, aliosque spiritus malignos, quia in perditionem animarum pervigantur in mundo, divina virtute in infernum destruum. Amen. In nomine Patris et Spiritus Sancti. Okay, take out your notes, please. I want to finish off the notes on non-real numbers. If somebody could dismantle the Leaning Tower piece of it, that's great. Yes, sir. The homework I will check off near the end of the hour. Refresh my memory if I don't. Because we didn't have any homework due today as such. That's going to be due tomorrow, Tuesday, because we didn't quite have all that. Let me just double check here. I'm just going to double check and make sure that's on screen.
It's not on screen. Okay. Good thing to check.
Those of you listening at home, hi. We are just doing a calibration. I'm going to see how far the camera goes. So it goes up to number 6. Okay. So here. I moved this. All right. I want to review a couple of things from yesterday. First, what is lowercase I? What does it represent? Sam? Imaginary. Now, specifically, what number? How do you get I?
It's radical -1.
Radical -1, correct. Whenever you take the positive square roots, which we call radical, of -1, you get an imaginary number that we call I. Nate, what is a complex number? Correct. What does that mean?
A is a number and B is a number.
What kind of number? Say it again. Go. A real number, yeah. A and B are real. And I is radical -1. This is called a complex number. A complex number is a real number plus an imaginary number. Any imaginary number is I, or 2I, or 8I, or some number times I. Okay. Now, can somebody tell me how to fill this in? Let's start from the beginning. Yes, good. Nick, what's I to the first power?
Radical -1.
True. And I'll just call it I for this case. What's I squared? Keep going.
I squared is -1.
How do you get that?
It says in the book right here.
Okay. Now let's pretend I close the book and I take away your notebook. Why is I squared equal to -1? Okay.
Well, if I is equal to radical -1, we square root both sides.
Not square root, but other way around.
Next, well,
Yeah, square.
Yes.
You're ready? I know what you meant.
Square it, and then you'll get I squared equals -1.
Correct, because the square and square root will cancel. Let me see. Jaylee, take over. What's I to the third power?
-1.
Correct. What's I to the fourth power?
1.
1. If you had some doubting person, how would you prove those? Where did I to the third power come from? Why -I? Another way to write it is -1I. Where did that come from? Anybody? How would you prove it? In other words, and if you got stuck, how would you bring it back again? I mean, it's one thing if we memorize something, which is nice, But if you forget a memorization, in math, it's kind of a luxury. You can often calculate it back again. You can find the formula again or find the number again. So where did I the third come from? Why negative 1i? I'll write a number here. I to the third is actually an exponent rule. Can anybody fill in this x to the third times x to the fourth? Abby, help me out with this. X to the what? If we did that.
12, or.
That's logical. 7, good. If it x to the third raised to the fourth power would be what? Yeah, x to the 12th. How did you get this top one? Is there a fast way to do that?
Just add them together.
Right. If the powers are on the same level, you add the powers together. This is I squared times I to the first. In other words, you split it up. Gentlemen, I'd like you focusing on me. Nate, take over. What's I squared? Negative 1. What's I to the first? What's negative 1 times I? Yeah. That's where it comes from. You can always split it up into smaller powers and multiply together. And you probably get the answer that way. I to the fourth power, just the same sort of thing. You can do I squared times I squared, which is negative 1 times negative 1. And that's where you get positive 1. Somebody tell me I to the fifth. Courtney.
Do I to the. Oh, wait.
You can do that.
Is it just I?
It is. How'd you get that?
Oh, I just remember it repeats every.
Correct. That's the quick way to do it. It repeats every 4. Then here's this new cycle, 5, 6, 7, 8. So what would the other 3 be?
Negative 1, negative 1i, and then 1.
Exactly. So, Spencer, help me out. What is I to the 40th power? Not I, but here's a hint. What's I to the 4th power?
Oh, it's 1, sorry.
What's 5 to the 8th power? What's that?
Wait. Yeah.
1. What's I to the 12th power?
1.
What's I to the 40th power? How do you get that?
It's a multiple.
Correct. Any power that's a multiple of 4 will give you an answer of 1. That will be incredibly useful, especially if I do this, or if the book does this, which by the way it will. I did the 325th power. You could count all the way out to 325. That takes a long, long time. There's another way to do it. If you remember that any power of 4 gives you an answer of 1. Watch this. This is not the only way to do it. Nobody's looking up here. Somebody tell me, Katie, what's I to the 320th power? 1. How do you get that so fast? Yeah, this is a multiple of 4. I to any multiple of 4 has to equal 1. I to the 5th. You can actually split that up one more time. Austin, what do you think?
I'm going to do I to the 4th and then I to the 1st.
Yeah, I like the I to the 4th. Why?
So it's just 1.
It's another 1. 1 times 1 times what?
I.
I. What's my final answer? I. Done. Okay. If you were sneaky, you could actually do I to the 324, I to the 1st. It's a little harder to see the multiple of 4. 320 is a pretty obvious multiple of 4. 324, it is, but you have to think about it a little bit more. That would be a little faster. You don't have to do as many steps. You see how I got that? All right. Can somebody remember this word for me? Conjugate. The conjugate of a complex number. I will say complex conjugate. Well, what is a conjugate? How do you get it? Should be in your notes from the other day. How do you get a conjugate? Go.
Could we just, so I to the 3.5,
Is equal to I.
yeah, could you just do multiple of 5 instead?
I wish. That would be so nice. And we're thinking like a multiple of 5 here.
Yeah.
And I'd like they work. Unfortunately, I to the 10th doesn't work.
Okay.
That'd be -1. So yeah, the only multiple, that's a very good question. But the only thing that works is multiples of 4. And then it'll be 1 more than that, 2 more than that, 3 more than that. So you have to kind of do it by hand beyond that. Yeah, nice question. What is a conjugate? Sam, if I gave you 3 plus 5i, what's the conjugate? Exactly. How do you get that?
You switch the sign.
Switch the sign of what? Because you didn't switch the sign of 3.
So the sign of 5.
Yeah. In other words, what's special about 5i? Why switch that? It's the what? What is I? Like, what's the definition of I? Radical -1. Let me try another one. Yeah, help me out with this one. What's the conjugate of 3 plus 4 radical 7? Yeah, that's all you have to do. 3 minus 4 radical 7. What are you switching? I didn't hear what. Switching the sign of the what? Go. Of the radical. Yeah, that's in your notes from the other day, but if you didn't get it, write it down. Getting a conjugate is when you switch the sign of the radical. Now, if you have 2 radicals, you just pick one. Usually the middle one is easier. But it's, you switch the sign of the radical. Now, why would we need conjugates? There's one definite use that we ran into last time. And that's what we call hostage situations. If you want to get a radical out of the basement, multiplying top and bottom of the conjugate is good. Let me do a quick review, and then I'll do a new one. 2 over 3 minus radical 5. 2 over 3 minus radical 5. Can I leave it like that? Blaze.
No,
Why not?
because you can't have a radical in the basement.
Correct. You cannot have a radical in the basement. So how do you get rid of it?
Multiplied by the conjugate.
Right. What would that be?
3 plus radical 5.
Yeah, 3 plus radical 5. And where do you do that?
Top and bottom.
Top and bottom. Write this down if you haven't already. Multiply by 3 plus radical 5 on top and bottom. Multiply by the conjugate at the bottom. Can somebody tell me what the top would be if you actually did that? Mary, help me out. Multiply the top one.
6 plus 2 radical 5.
Very good. 6 plus 2 radical 5. And how do you multiply the bottom? Look at it here. Putting in parentheses makes it a little easier.
Don't do it.
Go ahead.
So you do 3 times 3.
Yes, what do you mean? 9.
And then, do negative radical 5 times 3.
Okay, what is negative radical 5 times 3?
Which is
Negative 3 radical 5.
and then 3 times radical 5.
Okay, which is true.
And then negative radical 5 times radical 5.
What is that?
Negative 5.
Negative 5 itself. Did everybody catch that? Negative radical 25. Because negative radical 5 times radical 5 is this. Negative radical 25. But that's really a whole number. Well, a round number. Negative 5. This, by the way, if you're a fan of FOIL, it's F-O-I-L. You do the positive before the negative. Doesn't really matter. So does anything simplify there while you're at it? Go ahead and finish it off for me. Anything happen down here?
The 3 radical 5s cancel each other out.
Good. And anything else?
Do 9 minus 5, which is 4.
Yeah, 9 minus 5, which is 4. 6 plus 2 radical 5 over 4. We're almost done. The hard work is done. There is one last thing I would ask you to do, and this is something I'd like you to start practicing this year for all year and beyond. How do you simplify something like this? Well, first of all, quick example. Don't write this down, but just watch. 3 plus 6 radical 2 over 3. True or false? This is equal to 6 radical 2. False. Do you see what I did wrong? What did I do wrong that a lot of people who first see a problem like this attempted to do?
To simplify the 6 as well.
Yeah, I went bam. Bad. Do not do that. Even to say, oh, okay, fine, I'll put a 1 and a 1. Nah. If you have a plus sign, you can't just cancel a piece. The cure for this, 3, whoops, that's off screen for the people at home, just a second. 3 plus 6 radical 2 over 3. Here's how you do it. 3 divides 3, but it also divides 6. Here's how I do it. Is everybody familiar with this from algebra? We have a plus b over 2. If you divide the entire thing by 2, it's the same thing as dividing each individual one by 2. Does that look familiar? This is something I'd like you to commit to memory. The metaphor I use is, how many people do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Darn good. Even number of people. Let's just say Murgatroyd is sitting in the front here, and we have 14 people. Mr. Flibout from the Krebs game. Now, before we throw it back into state penitentiary, so, with all due respect, I'm declaring a math tax. Everyone in this room, let's assume you have $100. You'd be richer than I am. But I declare a 50% math tax. We can do it with 13 people, why not? And there are 2 possible ways I could collect the math tax. By the way, this is blatantly illegal. I'd be in prison to do this, but pretend I'm doing it anyway. One way is for me to go to each individual person and say, everybody has 100? Here, give me half your money, 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 all the way down the list. That's one method. It's kind of like what the government does. Second, everybody throw your money in one big pile. Blush. I take half of it. And then you divvy up what's left even. Got the 2 options? Which one would give me more money? Which method would give me more money? They're the same. Good catch. You see what? If I take half of the class's money, it's exactly the same as if I take half of each and every person's money. So I could have, let's say there are 4 people in class and I take half the money. It's the exact same thing as if I take the individuals and divide them by 2 as well. See that? That's a principle we're going to be using here. Dividing the whole thing by 3 is the same thing as dividing each and every one of those by 3. This is called, the high technical math term, split it up. 3 over 3 plus 6 radical 2 over 3. I would like you to do that. I would like you to split these up. I'm actually going to say that's a necessary step at this point, especially when we're talking imaginary and complex numbers. Because, can somebody finish this for me? Sam, what is this? 1 plus what?
2 radical 2.
Got it. And if you'll notice, there's no radical in the basement anymore. There's actually no fraction, which is kind of lucky. This is the exact same value as this. If you type both of these into a calculator, you get the exact same decimal. But this one is simplified. It has the radical out of the basement. It's reduced. Wonderful. Make sense? Now here's what I want to highlight. You know how you said that a complex number is a plus bi? This is what we would call standard complex form. The book is going to ask you from this point on and forevermore to write complex numbers in this form. A plus bi. A number plus a number times I. Why do I bring that up? Glad you asked. I didn't want to erase that. Let's try this. 2 over 3 minus 4i. Actually, let's do that. 2 over 3 minus 4i. Josh, take over. What do you do first? Okay, why? It's a radical. It doesn't look like a radical, but it is. It's radical -1. So what's the cure? Yeah, do what with the conjugate? Correct. Multiply the top and bottom by the conjugate, which in this case is what? 3 plus 4i. Can somebody talk me through how to do that? Spencer, help me out. How do you multiply the top? 6 plus 8i. Is that the exact same thing I did? Okay, good. No. How do you do the bottom? Back on. Foil. Go for it. Okay. Minus 12i. 16i squared. Excellent. Does anything simplify? Taylor.
The 12 i's cancel.
Good. Anything else?
The I squared can be -1.
Ding, 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 ding. Remember how I did the powers of I? That wasn't just for fun. I squared becomes -1. This is really -16 times -1. What is that really?
16.
16. So this is 9. This is plus 16. What is 9 plus 16? 25. It's 6 plus 8i over 25. Now it doesn't reduce as such, but there's one more step you need to do. Abby, what do you think? 2 thingies divided by 1 thingy. What do I want everybody to do? Split it up, exactly. Tell me what that would look like.
So 6 divided by 25
Yep.
plus 8 divided by 25.
Correct. And I would like you to do one last thing. I want it to look like a plus bi. So here's what I'd like you to do. This sounds gross. I want you to pluck the I out. And leave them as fractions. 6 over 25 plus 8 over 25 times I. That, by the way, is perfectly legal. Like 3i over 4 is the same as 3/4 I. The reason? 3/4 I is really 3/4 times I over 1. It'll give you the exact same thing. But I want to rewrite it as something is A plus something times I, where the I is separate. So that's what the book's going to be asking you to do. A plus bi, even if they're fractions. Doing okay on this? All right, let's take a look at the homework. We're looking at, for tomorrow, is do homework 1E as an Egbert. Page 25 thereabouts. Yeah, correct. Yeah, sure. A little caution, 19, 21, and 23 are going to be like the ones we just did. You'll have to split them up and make sure the I is separate. Some of the other ones are a little more straightforward. Number 25 should be relatively tame. 31. Yeah, one last reminder. Can somebody tell me what x to the -10 really is? It's probably the last thing I'm going to put up for. What's x to the -10? you raise something to a negative power, what does it do? What happens to it? Okay.
It's like, is it 1 over x?
It's 1 over x to the 10th, correct. So if they start talking about I to the negative 21st power, it's 1 over I to the 21st. That's not simplified. What you would have to do is 1 over, boil this down. I see I to the 20th, which is a multiple of 4, times I to the 1st. This is 1 over 1I. So see what I just did? Now get the I out of the basement. This is not a hostage situation, so just multiply top and bottom. It's 1I over 1I squared. I squared is negative 1. 1I over negative 1 is negative 1I. So I to the negative 21st is negative 1I. Everybody catch that? In other words, if you kick something into the basement because it has a negative power, simplify it down there, just like you did earlier. Just like you did I to the 38th power or something like that. Split off as many multiples of 4 powers as you can. Those boil down to 1. You notice I to the 20th power just becomes 1. And then boil down what is left. Okay? Questions? All right, the rest of the hour is yours. You get about 25 minutes-ish. If you get it done, you have no homework for tomorrow. If you don't, then take it home and enjoy. Call me over if you get stuck. Otherwise, go 2 ways. Oh yeah. Turn off the video.
Okay, this is signing off. Bye-bye, y'all. God bless your health.